So, you've got a security system up and running. That's great. But how do you really know it's working? I mean, really, it's just not enough to set it up and hope for the best. You've got to be proactive, you've got to test your own defenses. And that's exactly what we're going to do today by simulating a cyber attack using the Elastic Stack. Okay, let's just dive right in with the most important question. If your security system, your SIEM, is totally silent, does that mean you're 100% secure? Or could it mean it's just not configured to see anything at all? A silent SIEM, can be a really dangerous blind spot. So today, we're going to make some noise on purpose, just to see what our system can actually hear. So what's the game plan? Well, it boils down to this really simple but super powerful three-step process. First, we're going to launch a simulated attack. Then we'll make sure our tools can detect all the individual pieces of that attack. And finally, and this is the most important part, we're going to correlate those individual alerts to tell the complete story of exactly what happened. So here's the roadmap for today. We'll kick things off with why this is so important in the first place. Then we're going to get hands-on with a Linux attack. From there, we'll tackle the tricky world of Android threat detection, look at how to automate our adversary, and finally, we'll connect all the dots. All right, first things first. Why even bother simulating cyber attacks at all? Well, the whole point is to move from just having a pile of logs to actually creating an actionable story when something bad happens. We're testing the entire chain of events from the moment something happens all the way to that final alert. Now, to give our simulation some structure, we're going to use this awesome concept called the kill chain. It basically breaks down a really complex attack into separate, understandable phases. You can think of it like chapters in a story. We're going to simulate our own mini version of this, covering things like initial access, recon, and persistence, which lets us test our defenses at every single critical stage. Okay, enough theory, time to get our hands dirty. We're going to simulate a multi-stage attack on an Ubuntu server, and we're going to play both sides. The defender, that's the blue team, and the attacker, the red team. Okay, before we start the attack, we got to put on our blue team hats. We're the defenders now. First, we need to make sure our Elastic Agent policy is using the full Elastic Defend integration. That gives us deep security visibility, not just basic system metrics. Next, we're going to set it to detect mode. Now, why would we do that? Well, for this test, we want to see the entire attack play out from start to finish. And finally, we'll just double check that all the right pre-built detection rules are turned on and ready to go. All right, defenses are ready. Now for the really fun part. Let's switch hats. We are now the red team, the attacker. Let's pretend we just got initial access to this Ubuntu machine through SSH. And now, we're going to see what kind of trouble we can cause. Our attack is going to follow 4 clear stages. First up, a little recon. We'll run simple commands like who am I to figure out, who we are on this machine. Second, persistence. We'll create a brand new user called hacker_backdoor so we can easily get back in later. Third, we're going to try to set up a reverse shell using Netcat. It's this super versatile networking tool to create a secret channel back to us. And finally, we'll get ready to steal some data. We'll package up a dummy file and then encode it with base64, which is a classic trick attackers use to hide what they're taking. And this is where it all comes together. This is the payoff. Elastic Security doesn't just see 4 random commands. Nope. Thanks to our prep work, it generates a beautiful series of alerts that, as you can see on this timeline, form a perfectly clear sequence of events. We see the login, the recon, the new user, the reverse shell attempt, and the data encoding, all laid out in perfect order. This right here, this is the whole point. We've literally turned those separate, kind of confusing alerts into a story that a human can actually read and understand. A security analyst can look at this and immediately get it. An attacker got in, made a backdoor, and tried to steal data. That is the power of correlation. Okay, that worked great for a Linux server, right? We can install an agent and see everything. But what about devices where you just can't do that? This brings us to our next big challenge. How in the world do we handle the security blind spot of a standard Android phone? And that's the big challenge with something like a standard Android phone. There's no official Elastic Defend agent we can just install, so we can't get that deep process-level view of what's happening right on the device. So, what do? We have to get creative. Instead of watching what's happening on the phone, we're going to watch the network traffic coming from the phone. So here's our clever workaround. We set up our network so that the Android phone's Wi-Fi traffic has to pass through our Ubuntu machine, which now acts as a kind of gateway or listening post. Then, on that Ubuntu machine, we install Packetbeat. It's an elastic tool that just sniffs and analyzes all the network traffic passing through. With that in place, we can simulate an attack, in this case a simple port scan using Nmap, against the phone and see what packet beat hears. And whoa, the result is instant, and it is loud. The Nmap scan lights up the network, generating over 1,000 connection attempts in less than 30 seconds. From a network point of view, that is a huge, totally abnormal spike in activity. It's exactly the kind of thing that stands out from normal, everyday traffic. And you see, just like with the Linux box, this flood of network data lets us build a clear story. We can now confidently say that our monitors saw this massive spike in connection attempts coming from one specific device. And that behavior is a huge red flag for a reconnaissance scan, which means the device might be compromised. Okay, so running these commands by hand is awesome for learning, right? But let's be real, it doesn't scale. If you want to test hundreds of different techniques consistently, you need automation. And that brings us to this absolutely brilliant open source tool called Atomic Red Team. Just think of it like a giant library of pre-packaged, bite-sized attack simulations. Each one of these atomic tests is small, very specific, and, this is key, it's directly mapped to a known attacker technique in the MITRE ATT&CK framework. That's the industry standard playbook of bad guy tactics. This is what the pros use for repeatable testing. And you know what? Getting this up and running is surprisingly easy. First, you install PowerShell Core, and yes, that runs perfectly fine on Linux. Then, it's just a single command to install the Atomic Red Team module itself. From there, you can browse this huge catalog of tests. Pick one you want to try and then just invoke it. It'll automatically run the simulation and hopefully light up your security system with alerts. All right, let's take a step back. We've walked through a Linux attack, we've tackled an Android scan, we've even automated things. So what's the big takeaway here? Why does any of this really matter to you and your security team? Okay, let's just boil it all down to the key points you need to remember. Number 1. A silent SIM is an untested SIM. Don't trust the quiet. 2. Your goal is always to turn individual alerts into a coherent story. 3. You have to think like an attacker to find your own weak spots. 4. For those tricky devices without agents, get creative with network monitoring. And finally, use automation tools like Atomic Red Team to make this kind of testing a regular, repeatable part of your security routine. Look, if there's just one thing you remember from all this, please let it be this. Don't get lost in a sea of individual alerts. The true power of a modern security tool is its ability to help you build that complete narrative of an attack, to turn thousands of tiny data points into a simple, clear story that you can actually act on. And that really brings us to the end. I just want to leave you with one final question to chew on for your own environment. If an attacker got in right now, today, what story would your logs tell? Would they just show a bunch of disconnected, confusing events? Or would they tell a clear, compelling story that leads you straight to the source? Thanks for joining me.